Hello. So in this video, I'm going to look at the compound interest formula itself. Not so much how to use it because there's so many videos on that, but how did this formula arise? Like, why does it have the form or structure that it has? Okay. Now, the compound interest formula is A, which is the amount of, actually, let me put this in here so you can see it. This is where we're going to get to. A is the amount that you actually earn. P is the amount you invest. It's called the principal. R is the interest rate that you earn. N is the compounding, which is how often the interest is calculated. So let me just put that in here. Compounding tells you how many times in 1 year interest is calculated. So for example, semi-annually is twice a year, quarterly is 4 times a year, monthly is 12 times a year, daily is 365 times a year. And then T is the years that you leave the money in there. Now, what I'm going to do is I'm first going to work with just the annual compounding, meaning you calculate interest at the end of the year, and that's it. So in that case, N is 1, so the formula becomes this right here, and that's what we're going to start with, okay? So, suppose you deposit $100 in an account that pays 5% interest compounded annually, and as we mentioned, N equals 1. Well, the old school way of doing this would be to say, I'm going to have at the end of the first year, and this is the end, you're going to say, oh, well, I have $100, right? That's the principal. Plus, you have the interest, right? So that's going to be 5% of 100. So that's going to be $100 plus $5, or a total of $105. So at the end of the 5 years, if you were to take out all your money from the account, you'd have $105. But let's say you leave it in there and you look at the end of the second year. Well, you left the $105 in there, so now that's actually your principal. So it's $105 plus your interest, which at the end of a year, you get your $105 and you get 5% of that, right? And so that's going to be $105 plus $5.25 for a total of $110.25, okay? And we're going to go to the third year. I think that's enough to see a pattern once we break it down a little differently. So at the end of the third year, let's say you left this money in there, so now it's your principal, right? So you get that back, plus they need to give you 5%, right, of this $110.25, which is $5.51. You can see they're not doing me a lot of favors, right? A 26-cent increase. So at the end of the 3 years, you have $115.76. All right. Now that would be nothing wrong with this. This is perfectly fine. It's just that you don't see a pattern with this. So what I want to do then is go through the pattern. All right. So what happened then? Let me kind of carry this down. At the first year, what we said is, I'm going to kind of keep this over here. We had $100 plus $100 times 0.05, which I'm now going to factor out the $100 and say, well, that's times 1 plus 0.05. Okay, we can put the 0 if you want. So that's your $105. Now at the second year, what happens? If you recall, you had your $105, right? You had your $105 plus your $105 times 0.05, right? But what I'm going to do is I'm going to factor out the $105. And so 105 times 1 is 105, and 105 times 0.05 will give you the 105 times 0.5, right? So that's this right here. So this line represents this line. But remember, we said 105 was the same thing as 100 times quantity 1 plus 0.05. So I'm going to write here 100, oops, just write that out, times 1 plus 0.05, but then times again now 1 plus 0.05. All right, so that's really 100 times 1 plus 0.05 squared. All right, that's at the end of the second year. Notice it's squared. In the first year, we have it really to the first power here. let's go to the third year. Right? And in the third year, you had here $110.25 plus $110.25 times 0.05. So I'm going to write that 110. That's the way you'd calculate it, right? Times 0.05, right? Now, so that means now what I'm going to do is say, okay. Oh, by the way, this here was what? 110.25. So I'm going to factor out the 110.25 times 1 plus 0.05, right? That represents this. But now I'm going to represent the 110.25 and say, well, but we said that is right here. This is 100 times 1, oops, times 1 plus 0.05 squared. So that's this part right here. Times now 1 plus 0.05. So that's really 100 times 1 plus 0.05 cubed. And notice what we have here. In the first year, my cat's going to help us. T was 1. In the second year, T was 2. Third year, T was 3. So essentially what you can see then is that for n years, you would have A is equal to your $100 times 1 plus 0.05 to the T years, however many, or oops, let me just say T years, not N years. Whoops. T years. So that brings us to my cat sitting on everything. Hold on. Loves to join us. So that brings us to this right here, the annual, compounded annual interest formula. All right. So now what is this N business? So remember I said N is the number of times that they calculate interest in 1 year, right? So, so this is N. Well, these are the different ways they usually calculate them. Either semi-annually, quarterly, monthly, or daily. So it's basically 2, 4, 12, or 365. Okay. And why does that have to be introduced in there? Well, here's what happens. If, for example, I compound the same problem, but I do it semi-annually, right? The $100 at 5%. Well, at the 6-month mark, at half a year, when I go to calculate your interest, I'm not going to use the whole 5% because you haven't given me the use of the money for the whole 5%. So I'm only going to give it to you for the time that you've given it to you, which is half the time. So I'm going to do 0.05 divided by 2, or 2.5%, right? So at 6 months, right, I'll give you, for example, or you'll earn 1/2 of the interest rate for a year. Right, so you're going to have 1/2 of 5%, which is the 5/2, where N equals 2, because you're calculating interest twice a year. But I'm doing this twice, so what happens is, so there's your R over N, right? Here, your T, you have to tell me how many times you're doing this in 1 year, so you're doing it twice, 2 times in 1 year. So that's how they come up with this whole compound interest formula right here. And then they've got lots and lots of examples for you to study and see how you actually work with the formula. Thanks so much for listening.